Water coolers for us are a time when we get together, we chat informally. It's a time for learning from each other and for questions from the community. And these can either be presentations from the community members themselves, so educators and partners, or we bring in outside information and do a little mini professional development, sharing some additional resources from the community and often our parallel communities from NASA and NOAA, et cetera. So I'm going to turn it over now to Erin McKinley, who is going to introduce our speaker. And I'm just really thrilled to have this opportunity. And I think, Todd, you were the one that brought this to us, right? Yes. So I learned about GOES, and I actually see on our Globe website, like we have the a webinar about one of the predecessors to this particular one. So that was really exciting. I saw that today. So I feel like we're updating our Globe website webinars with the new stuff. So I'm really excited to hear about what you're going to present.
Thank you so much, Jennifer. Thank you so much for inviting both myself and Andy to this wonderful opportunity. I'm a big fan of Globe, as being a part of the NASA education world for many, many years. And so I'm thrilled to be now part of the GOES-R and GeoXO programs. For those who don't know me, my name is Erin McKinley. I'm the Senior Outreach Manager for the GOES-R and GeoXO programs based at NASA Goddard Space Flight Center in Greenbelt, Maryland. I'm thrilled to be introducing our special guest today. Andy Heidinger is the NOAA NESDIS Chief Scientist for Geostationary Satellites. He is concerned with all things GOES, but he is mainly focused on the next generation of GOES called GeoXO. He lives in Madison, Wisconsin, and has an office at the University of Wisconsin Sims. And most importantly, he is a big fan of GOES imagery, and today he's going to share that love for GOES imagery with you all. So I'm going to hand it over to Andy. Take it away.
Wow. Thank you. Thank you for that wonderful introduction, everyone. So I will share my slides. As I predicted, my other computer did freeze, so I will attempt to share my slides. And not a Zoom person. I see this. I see the button. So I'm going to start that and you to a full slideshow. How's that? Do you guys see? Good to go? All right.
Looks great.
So, yeah,
looks great.
I'm Andy Heidinger here in Madison, Wisconsin, a NOAA employee. Big fan of GOES, and GOES is easy to sell, as you'll see. So, what is GOES? So GOES is two eyes in the sky, one over the Pacific Ocean at about 137 degrees longitude, west longitude. You can see it. It sees the western U.S. all the way to New Zealand in the bottom left corner. And then we always have GOES East sitting at 75 degrees. And that sees, of course, South America, all of North America, and even a little bit of Africa on the very edge of the scan. So we cover, a big part of the world of the NOAA GOES program, and anything in these domains you can see in a very high resolution image roughly every 10 minutes. So maybe you've seen GOES data before, but this new generation is tremendously powerful in resolution, both time and space. So I'll go next. So the history goes, I always like to talk about the history because it's pretty long. So we go, the first weather satellite, I think, was around 1960. And so that was just a poor orbiter. But by 1975, and actually there were some predecessors, we were launching GEO. And GEO is a very, very long way away from the Earth. It's 36,000 kilometers, or six, if you take the diameter of the Earth, a line all the way through the Earth, multiply that by 3. That's how far away our satellites are. So we've had several generations. The current one is GOES 16, 17, 18 now, and hopefully 19. And It has this ABI imager, which is this really very successful, really introduced this revolution of imaging from space. We also have a lightning mapper and space weather. And that was first launched in 2016. It takes about 20 years or less to put the program together. Then they last for about 20 years. So we are deep in the work for the next program, we'll call it GeoXO, and that's going to launch in 2032, the first one, and that's going to have a whole bunch of new instruments that I won't really go through here, but it's going to be a pretty cool increase in our capabilities. But everything I show here today will be on GeoXO, but it'll be a little better. And in this current configuration I have with one screen, I can't see if anybody's waving their arms to ask a question or telling me something. Just interrupt me if you have a question, and feel free, of course, to interrupt me at any time. So another thing that we didn't understand with GOES-R at the beginning, we knew it was a great sensor, and we knew we could make a lot of products that talk about clouds, aerosols, rain, winds, how hot the surface is, what is on the surface, storms, you name it. It's kind of illustrated by this cartoon here. But it's really turned out that by far the biggest usage of GOES data has been imageries. And I'll use the term RGBs, red, green, blue images, kind of this, the colorful, could be true color, could be fake color, but those images have really stolen the show from these level 2 products. Of course, I spent most of my career working at level 2, but of course I love imagery, and this is and it's now so readily available to get, and I'll talk about that as well. So I'm going to talk a little bit about the GOES-R review, so to understand what these images are. Here is a 16-channel composite of the GOES East over the USA for just one random image, I think taken probably years ago. So the images that are black and white, those are images that are taken from sunlight reflected off the Earth. And we have 6 of them, and they give us a lot of different information, but they're only up during the day. And the rest of the colored images are called thermal, where most of the information comes from emission from the atmosphere and the surface and the clouds and the aerosol. And what you can see there, the ones that are kind of red and yellow, those are window channels. Window channels mean they can see all the way to the ground. So if there's something on fire, or you want to measure the temperature of the surface, they basically can see all the way to the ground. They're all different in that they measure different parts of the atmosphere and have different sensitivities. But the ones that look different, have a lot of whites and golds. Those are channels that we're looking at the absorption. And you may notice you can't really see the surface too well in those channels. But those are the channels that give us information about, how much water vapor is in the air, what the temperature is at a couple levels. And they really help us, we can predict storms. Storms grow where temperature and moisture allow them to grow. So if we know where temperature and moisture are converging or diverging, that really helps us. So this has been a great success. I'll keep going. Oh, I guess we got a little animation. So it is an important point to make that we have the RGBs in true color. You need a red, a green, and a blue. So we got a red and a blue, but we don't have a green. But we've been very lucky in that we can fake it from some of these other bands, especially the 0.86. So when I show you true color, it's not really a true color. It's actually a method to fake it, but it looks very good, and nobody seems to complain. And we're going to stick with this paradigm going forward in GeoXO. I'll just show a couple bands again, just straight up. This is band band 2, the 0.64 micron, this would be a visible band. This measures in the frequency that your eye sees. You can see this is like we've always measured this band. It sees clouds very well. Surface is dark. The ocean's very dark, and this is what we call the visible band for many years. We now add other bands like this one. Here, the clouds and the water are the same, but the surface now reflects, especially vegetation. So we can use this to see the health. We can help farmers and foresters. We can measure the health of the vegetation through this. And this one, the 1.38 micron band, this is a band, it's solar reflectance, but the water vapor absorbs a lot. So you'll rarely see the surface. So you can see high clouds, they pop out where they don't before. So if I toggle back and forth, like if you look around Lake Erie and Lake Huron, it's very evident where the clouds are, much harder to see in this band. So putting all these bands together, you get a very powerful look. Here's an infrared band. This is a window band. Again, you can see clouds in the surface. Clouds are very cold, so we tend to make them white. So it just seems to match our eye. And then we throw a color bar on top to know where the clouds are coldest. That tends to be where the clouds and the storms are the strongest. But you can see here, this is a day in June where the land is warmer than the ocean, than the Great Lakes, so they're darker. And then if you go to this one, this is the same time of day, but it's a water vapor channel. So you don't see the surface anymore. You see the clouds and you see these structures of water vapor. Again, that tell you a lot about what's going on in the atmosphere and what's going to happen in the future. So RGBs. So how an RGB is made. Maybe you have a projector at home. It'll have a red gun, a green gun, and a blue gun, and putting an image through all three of those makes an image on the projector screen that could be any color. So that's what we do with RGBs, and this is a particular one called the cloud type RGB that I was involved with in its creation. And in this case, we take the red channel from the 1.38, the channel that's very sensitive to cirrus clouds. We take the green channel from the visible, and we take the blue channel from another band called the 1.6. And you can see that the combination of these three things makes a very, I think, pretty and informative RGB. And using these three bands, you see that the ocean and the clear land are very dark. The water phase clouds are kind of this turquoise color. The snow in the Alps is a very strong green. The cirrus clouds are red, and the strongest convective clouds are yellow. So again, a lot of information comes from these three independent channels. RGBs make it easier, and you'll see a lot of RGBs going forward. Another kind of cool thing is that they are just images, but people get very experienced with what they mean. So this is a kind of a glossary for this particular image, this RGB, of what all these colors mean: the green, the cyan, the yellow, the reds. So this is actually EUMETSAT, our partner agency in Europe, has developed training tools for this and many other RGBs that if you wonder what would that yellow thing be, it'll tell you that's probably a thick high level ice cloud and everything else. So if you have a favorite RGB, it's good to know what you're looking at. And I'll just point out the GeoXO program has worked with its training groups. One of them is at CIRA, and they've put together these quick guides. So I show an example of the page that if you go to this link, you'll see a whole list of quick guides that you can look at to understand all sorts of things, including products, but also these RGBs. And if you clicked on the CIRA quick guide for this RGB, you'd see this. It tells you what it shows, what its recipe is, and some of the impacts it has. Okay, I see. Is there a chat question?
Yeah. Will we get a copy of the slides?
Absolutely.
Excellent. Thank you.
Okay, so I'm going to show a couple RGB examples I think are pretty. So this is taken directly off the Sierra Group's page. This is straight up. This is that fake true color, I can call it, an approximation, but it looks so good. So this is probably the most common RGB you'll see from GOES, and beautiful imagery. You can stare at them all day, and your eye gets very well trained to what they show you. Let's see. Next is kind of a cool RGB. Fires are a big deal out west. So what we've done, I think Sierra may have done this first too, is taken that true color RGB and then detect hot pixels and give them kind of a fire-like color. So you're not seeing the fire really, but this image makes you think you are. You're just seeing the heat. But it's really popular, and it's really kind of neat. And you can stare at these things. The resolution is good enough. You can see smoke plumes coming out. You can even see when the fire is intense, it'll get yellow. And sometimes you'll see even clouds. There's so much buoyancy from the hot air. Sometimes you'll see clouds form, and they can be thunderstorms as well, and then cause other fires. That's again, that's worth another look. This is in the Great Valley of California. I forget the fire, but there's so many fires now. Yeah. And lastly, those RGBs were only good during the day. So one needs to, if you want to see things at night, there's also RGBs, but they're made from the thermal channels, and they tend to take a little more experience and exposure to get used to them. So here's one called the air mass RGB. Clouds are very evident, and you can see low clouds from high clouds. But in the clear air, you can also see moisture plumes because the water vapor channels are used in there, and it's very useful for just seeing the advection of moisture throughout the satellite image. This is a scene over Alaska, so it's kind of at a high angle for GOES. But these are big storms. They bring in often something called atmospheric rivers, where you can just see a whole train of water vapor moving from the Pacific to hit the West Coast. And this is a good air mass to look at. I also want to point out, GOES can do very well at higher latitudes. So these are probably, well above 60 degrees latitude, and the resolution of GOES is so good that the images are still can be very useful for this. Please ask any questions. So, okay, that's a little primer on what goes into an RGB. I will now talk about what I think are the 4 most common ways that people can get RGBs. I know there are probably more. I'm sure there are more, but these are the ones, at least in the NOAA universe, I think are the most common. The first one is the NOAA NESDIS star page that I think is probably the most well used. There's one here at SIMS called Geosphere. There's one at Sierra called Slider, and the College at DuPage has a very effective site as well. I've listed here these links. So I'll first talk about the GOES image viewer, which is from NOAA NESDIS star. And if you go to that page, you're confronted with this. It's a very simple interface, which I think is the strong, It depends on your personal preference. But this is a very simple interface. It's actually the source of the data that you see on, if you go to their National Weather Service forecast images. I'm not sure how many people go there. I do. It's our NOAA Weather Service pages. But if you do, to get your forecast discussions or your forecast outlooks, if you go to additional resources, they'll have radar and they'll have a satellite image, and the satellite image is actually points to this site. So, and another very, I think, important thing about this is they offer data at quite low resolutions, so 339 by 339 pixels. So if you're on a phone, it's very useful to use that. And you can see they offer different domains. So CONUS would be over the United States. Full disk could be the whole, of course, disk. And they've broken it up into some other sectors. Very, very nice site. And here are actually a list of all the sectors. So if you are just interested in the southeast of the United States, you can just bookmark your favorite RGB over that region, and it shows all the regions you can get. One really cool thing about GOES is that we have what's called mesoscans. You'll see. So mesos move around. So if we know there's going to be some big event, could be severe weather, it could be fires, it could be a rocket launch. People will pre-order mesoscale scans, and those are relatively small. I think they're 1,000 by 1,000 kilometers, but they're every minute. So, they're very insightful for dynamic things like severe storms, and they can go anywhere across anywhere GOES sees. People can call up a meso. They can be called up by universities. If your university is doing a research field program, we do mesos often to support that, as long as there's not a compelling reason that we can't. Here's just a couple, examples of, these are GIFs, animated GIFs from the NOAA NESDIS GOES viewer. One on the left is, again, this GeoColor. And you can know the GeoColor is only during the day, but at night you'll see the city lights, which is a background image. It's not in real time, with an overlay of the infrared. So there's always data there, but during the night it looks quite different than during the day. And I show the air mass RGB on the right. You can see the storm system coming in. I always choose Wisconsin. Actually had very severe weather. So Wisconsin and Iowa had quite severe weather. I don't know if the UP had any, but you can see this dry air in front of it, and a lot of the hallmarks of severe weather. And again, you can also show things like lightning. Lightning is another instrument on the ABI. The NOAA NESDIS star viewer lets you show, you can load lightning on top of it. So what the color is a GeoColor image. The colors shown, the reds and the greens, is how much lightning was recorded over, I think, a minute or 5 minute period. So it's cool to see lightning. It's almost like I don't look at a GeoColor image now without putting them on. So Cirrus Slider is probably one of the most innovative sites, and they're the ones that make the recipes that you see on the site I just showed you. It's a very different interface for those that you're presented with just always a full disk image like this of GeoColor. You don't have the predefined just click the image. You have to go through their menus, but it's quite more powerful, I'd say. You can really refine what you're looking at. You don't have predefined regions, but you can always zoom in. It's very similar to like a Google Earth. kind of interface, I would say. And what's good about, I think this one is, there's an archive. The archive is about 3 weeks. So if you, miss, the previous one was only kind of in your real time. But if you miss something, this has a 3-week archive for you. Goes east and west, but also has the other geos as well. So it's if you're interested in what things look like all around the globe, this is a great site. Again, I'll just show some examples. This was yesterday, the severe storm outbreak over Iowa and Wisconsin. GeoColor, again, it's fascinating to look at. It's, kind of matches what the eye would see, but it's not always the most informative. You can't really see the difference between ice clouds and water clouds. So they also let you put the lightning on. So here's the lightning, and this really lets you tell you where the lightning, where there is lightning, there is a convective core that's pretty strong. So you can, you can't see that in the regular image very well, but lightning does a very good job of identifying those things. Radar is also very cool, of course. This is the national composite of the NEXRAD radar. So Slider also lets you put this as an overlay, and I think this is very interesting. Radar only sees precip, snow or raindrops. So what you're looking at is the movement and the strength of the amount of precip in the column. So people want to know where it's raining, and this is a very useful thing, and it tells again where is the strongest convection, and of course all the dynamics that NEXRAD, people that are trained how to analyze NEXRAD. And lastly, I show just another RGB. It's a cloud phase RGB. The true color is great, but there's signals of what's an ice cloud, what's a water cloud, that are missing in the true color. You can get it by combining, as I said, these different channels, and just a wealth of information you can get. And Slider, I'll say this is my product. This is the cloud top height, but Slider shows this as well. So if you want to know this, images can only take you so far. If you're a pilot and you want to know how high those clouds are, if you want to avoid them, it is still important to be able to look at the level 2 data, and it'll tell you, in this case, those clouds over Iowa are 13 kilometers high. So I'll touch lightly on a couple other ones, and so time is certainly running by. So CSV Geosphere, it's from Sims. It's different. It's a very, very simple interface. It only shows the true color. It has no predefined regions, and it only goes east and west, but it's very, very, very fast. And this probably makes, I think, maybe the best imagery by my eye. So if you're only interested in true color, in a nighttime RGB, this is incredibly fast. Doesn't have the radar, the lightning, which is too bad. But again, if you're just infatuated with true color, this is a great one to go to because it's so easy, and it also has an archive. So, and you can pick. Again, these are all very interesting interfaces. You can very well specify what images you want to find. If you're looking for something exactly that happened in your neck of the woods, you can only show that. Shows all the bands, only one RGB, and again, the cloud top height and cloud top temperature. So they make MP4s. As I say, I mean, some people like MP4s. They're a little smaller. Sometimes they're a little harder to use than the animated GIFs. But this is a case of, I took this over Brazil. This is CSVP Geosphere. Maybe it's not coming through on this display, but the level of detail and animation that they have is very nice. So lastly, College of DuPage. It's another like very, very simple interface that people like very much. So this is the front page of DuPage. You know, very simple. You have a menu on the left. You can select all the channels. It has a radar on it as well. So maybe this interface is what you like. What I think is cool, it has predefined domains. So if you always want to see the Great Lakes, you can just always go to the Great Lakes domain. You don't have to set it up or do any searching. It's very easy to do. It also has Alaska, Hawaii sectors. I think it only goes east and west though. So here's an example again. This is the Midwest sector. This is an animated GIF that they make. Animated GIFs I find very easy to use. And this here is a visible image. It's called a sandwich. So what this is, it takes the visible data, which is has the most highest resolution, and sandwiches on top of it the infrared. It kind of gives you an information for ice clouds only. It gives you information on how high the clouds are. So it's a very popular product. And yeah, you just stare at this all day. You can see the small scale popcorn cumulus over the southeast. And all this stuff was just not as good in the previous generation. And we'll get 4 times better, at least in terms of resolution, for GeoXO. So I made a little summary of these 4. I thought, the attributes of these 4 things. So, it depends what you want. If you want an archive, you're limited to Slider or Geosphere. If you want MP4s, you're limited to some. If you want radar, you have to go to Slider or DuPage. So, and these sites are actually I think they're very competitive with each other. So they're always getting better. And if you have like a request of that you want to see something, they really do like to work with educators and just the general public to make the data better. So with that, okay, I'm almost done. I just wanted to point out there's other notable sites. So CIRA and SIMS both have like blogs. So CIRA calls theirs a satellite library. SIMS calls theirs a satellite blog. So I find these to be very, very interesting. Every time there's a big event that happens in the United States or the world, you'll see these events, satellite imagery and analysis of that imagery in these blogs. So CIRA tends to have, I would say, better imagery. SIMS tends to go more in depth, I think, maybe less. I'm not sure who reports more, but they'll have more of a meteorological bent on what's going on. NASA Worldview, I think people are familiar with that. That's just starting to show GOES. And we have Twitter or X accounts for NOAA and NESDIS that are always pumping out cool satellite images. Okay, that's it. So I'll stop sharing. Now take any questions that you have. Thank you.
Well, thank you very much. I'm like overwhelmed and excited to to start viewing some things.
Yeah, just grab the it's those links. It's very immersive. So the data is incredibly beautiful, and yeah, it sells itself.
Are there any questions from our audience? I have one, but it might be a little out there.
Fire away.
I was wondering, with the increase that we're hearing about turbulence, and I know that they say that there's there's nothing out there that's really good at looking for turbulence. But do you think in the future there's any hope of that in some of the
Yeah.
products that we can put
So
together?
yeah, we do have a turbulence products, and so turbulence. I'm not an expert in turbulence, but one way turbulence is made is when there's a strong updraft, a storm. It'll send out gravity waves, um, emanating out from it, and sometimes those get damped. Sometimes they amplify, and we could see those um, under some conditions very well. So, like there was just a horrible case yesterday of a Singapore flight where I think a person died. The aircraft dropped 6,000 feet. Now it's turbulence, and that was actually what was detectable by in this case it was the Japanese fly a very similar sensor to what we fly. So yeah, I mean it sometimes other clouds get in the way of seeing those gravity waves, but yeah, for a good part of it, yeah, we do all right.
Well, thank you. 'Cause I did not know that.
Now you do.
Now I do. Good to know. And I think that that's going to be something that they said that that could start happening more and more is more turbulence
Well,
in.
yeah, I think global warming would lead to, I think, fewer but stronger updrafts. So, um, the updrafts that happen will be more likely to spawn these gravity waves that could cause issues.
Hmm. All right. Other questions? I got mine answered.
See,
It looks
Aaron
like
put a link of some more materials about the GOES-R mission.
Are you close to pinpointing where the tornadoes would touch ground?
Are we able to tell when the tornadoes will touch? Where are we able to predict where tornadoes will touch down?
Yeah.
No, we try to help. We do help in the prediction of tornadoes. It's an all hands on deck though. So this is where AI and machine learning have come in. So after the fact, we know where tornadoes were and where they touched down. So we've built over the years quite a training database. So the ABI and radar and the lightning feed into these kind of these deep learning networks, and they actually are showing quite a bit of skill to extend the lead time. So now, I mean, but by like 15 minutes, clouds have to be there, things have to be forming. So you can't look in the future hours. But with the imager and the lightning mapper and of course radar, yeah, they're getting much more skilled at saying, hey, that cell over Kansas City, that's the one that's going to spawn a tornado, and that cell over Des Moines, not so much. And they're quite skillful. So, but tornado hitting the ground, no. But a tornado being present, yeah, they're getting pretty good.
Okay, that's good. Thank you.
Thank you.
if you could identify one step that we could give teachers as like the first step to starting on their GOES journey, what would you recommend?
Well, that's a good question. So I don't know. I mean, I would think if I know my kids aren't even though they're my kids, that they're not looking at RGBs, they're not looking at GOES-R data very often. So I think it would just be cool to have assignments where they can look at the RGB and go outside and explain what you see and why you see what you see, and I think that would be fascinating. Because you can see on the ground, you can see beautiful cirrus clouds streaming overhead and things, and you'll see that in the satellite very clearly, and that's to be cool to relate the two. I think it's my best guess.
Thank you. There's a question over here. Are there questions where data collected by citizen scientists could help answer?
That's a good one, Jessica. Yeah, I think so. So, I mean, the most difficult part of like AI and machine learning is getting a set of data that's labeled, that that tells you what you're looking at. Because we got a lot of data, but sometimes we don't know what we're looking at. So I think the data collected by citizen scientists, that hey, it's hailing here or it's not hailing here, could really help those kind of things. So, and I think it's going to get easier and easier as citizen science gets more and more, widespread. But that is, I mean, I do some machine learning. That's where 90% of the effort is. It's not being smart and training the model. It's getting the input that's has enough information to it.
John Moore's reminding us that there's a GOES page on the Globe website with suggested activities. Thank you, John. Do you have that link? If you have that link, to just stick it in there, and then we can make sure we put that on there.
I'll find it quick.
Okay, thanks.
It's under the, because I don't get time to get back to, it's just look, Google satellite missions for Globe. And that's a page where all the Globe satellite connections, it's on that page. I'll look it up quick.
Okay.
Okay, so is this the group that used to takes cloud observations and would give them to NASA? That's okay. I remember that. That was quite a while ago. It started a long time ago, didn't it?
It did. Yes.
29 years ago.
Although I don't know that the satellite matching goes back that far. Jessica would know that's not quite as far back as the beginning of Globe.
I am really excited to add in. I did not know about the RGB classification that was done. You said by a group in Europe. Is that right?
Yeah, well, those quick guys I show, that's what they show. So they kind of, every RGB, it's a pretty image, but people get really good at knowing what magenta means or whatever. So that's interesting. And if you have a favorite RGB, you too will become an expert in that RGB.
I would love to take that particular, classification, right, that they're getting, and then see what my classifications are.
Okay.
Because it was like, it talks about the amount of moisture, right? Ice, and then height, right? Is that a lot of it was about that?
Yep.
Yeah, which is what we need to know.
So we
for our
measure it.
classification. All right. Anything else? Oh, there, John put in the link there for us. So for the GOES-R. Other questions? We have 2 minutes. So this is your last call. 2 minutes before the top of the hour. I like to end on time.
Feel free to reach out to me for any further questions. And Aaron too, of course.
All right. So in my last minute, I'm going to thank our presenter and thank you, Aaron, also for the introduction to our presenter. Thank you to Todd for bringing this idea to us.